Okay, hello students. This one is lesson number 13 and this is about polynomial division. Last time we have seen using box method, how do we divide a polynomial by a factor. So this lesson we are going to use long division. If you can see this, I want you to write the work before we begin the 13 practice problem. I want you to take a note of this. One example we'll solve together, and that one is, let me pick any one. Okay, this is the one. So let me pick this one and see how do we divide this. Okay, have a look at this. What does it look like? Remember in the, we did with the numbers. Let's see if I'm writing 5 and then divide to, let's see, 17. Okay, what does it mean? Actually, you are dividing 17 divided by 5. It means you are in the quotient form, it is 17 divided by 5. And when you work this out, 7 goes how many times, right? 7 goes, the closest I can think is 5 times 3 is 15. And when you change the sign, so in the beginning it was plus. So all we do is you subtract. So when you subtract, basically you are changing the sign of this becomes minus. So it's like 17 and minus 15, which is 2. So the remainder, this is the remainder. And we write it as R, and this is the divisor D, this is the dividend D, and this is the quotient, right? So it means we can write this whole thing, this dividend. So when you write this, this means it is the, so when you divide this, it is a quotient. So it is a quotient is 3, so it is 3 plus, and the remainder is 2, so 2 divided by 5. So this is in the form of Euclidean algorithm. It means it is d divided by divisor is quotient plus remainder times divisor. So this is one way to do, or you could also write dividend equals divisor time quotient plus remainder. What it means is the 17 is same as 5 times the quotient was 3 and plus the remainder was 2. So it's the same thing. Basically, all you do is you times, there's a d, right? So you times d, you times d, and you times, here, I think I forgot, this was d over small d, and you multiply d. So this goes away, not here. And you get, uh, I'm sorry, I messed up here. So let me write this whole thing again. So dividend divided by divisor is quotient plus remainder over divisor. So I'm multiplying by d everywhere. So you multiply everywhere d and this d crosses over. So this d goes away. Uh, oh, you're not. Yeah, this also. So divisor becomes equals quotient. Or instead of that, you can write other way around. So divisor times quotient plus remainder. Why I'm showing this, let's see. So the reason is this 5, now this, when we divided by 5 and 17 divided by 5, you got the quotient, but the remainder was a number 2, see? So it doesn't go equally. If it was 5 and this was 15 and 5 divides 15 3 times 15, and when you subtract that 0, so the moment you get remainder 0, so this 3, so 5 is a factor. So we say, hey, 5, if this is the case, then we say 5 is a factor of 15, because when you divide, you get 0. Here, when you divide 5 to 17, you get 2. So this is not a factor. So the same idea is used in this division. So let's see what that means is we are trying to find. Let me go directly. So let me take this up and do it one more time. So on Wednesday and Thursday, we have seen how to do using the box method. So I don't want to go to the box method because it will take time. You can check the video that we did last time. I'm gonna go directly use this. This is the divisor, right? So all your all you do is you this thing. So the step one is this is the first one, 2x. So this 2x cube you divide by this 2x. So when you divide by 2x, you can see this 2 goes away and you get x squared, correct? And that x squared that you get, you times, so this is x squared, you put the whole thing now, 2x plus 1. And use the distributive property and you get 2 times x, 2x times x squared is 2x cube, and this one when you multiply that, you get x squared, and this is what you put right here. So this x squared that you get, which this one you put it up here, okay, and these two things you put below here, 2x cube plus x squared. So again, I repeat, so start with this 2x cube, divide this, the first 2x, and you get x squared, that you put up here, and then again that same thing you multiply to the divisor, use the distributive property and get that. So now next is, you need to subtract this. When you subtract, remember you have to change the sign. That means this thing, it was positive here, so you change it to minus. This was positive, change it to minus. So no more positive, this positive. I'll take that off, okay? And then we can cross out. This thing crosses out, get 0, and 13 minus 1x squared you get. So you get 11x squared, 12x squared. Then bring down this 16x right here plus 16x and repeat the same what the steps. So what are the same step is this time there is a 12x square, right? So you take this 12x square and then divide by this 2x, and you do that, you see 2 divides 6 goes, so 6, and one of the x will go and you get 6x. So this goes right here. And then multiply this 6x to this whole divisor, so 2x plus 1. So this, when you multiply 6x to 2x, become 12. X times x is x squared, and 6x times 1 is 6x. And that you put it right here, 12x squared. This whole thing you just write it here, 16x, right? So this is 16x, so plus 6x here. And then you subtract. So subtract. So when you say, let me write here, subtract. You know, so this will go away, and 16 minus 10 is 10x. Then bring this 5 here, so that becomes plus 5. And do repeat the same step again. And this time, all you do is you pick this 10x, so 10x, and divide by this 2x. And you see 2 goes 5 times x crosses out and you get just a 5. So that goes right here. And then it's like you're multiplying here 5 times 2x is 10x and 5 times 1 is plus 1. I did not show this step here. Actually, this 5 that you get, you multiply to the divisor 2x plus, and then use the distributive property, you get 10x, and 5 times 1 is 5. And that's what you put right here. I think I forgot to put a 5, and then subtract this. And when you subtract, I know it takes a while, so this changes the sign, this 0 and this also 0. So the remainder, and that's the good news, that remainder is 0. And you will see there will be a remainder theorem which says when you plug in the value, this one, x equals opposite of plus 1 is minus 1 and divide by 2. If you plug in and you get answer is 0 in this one, then we say it's a factor. But we are using long division. So this is called long division. What did we learn from here is this was the dividend. Look at that. So it was 2x squared plus, okay. And all we did was equal sign. We used this quotient, that is 2x, sorry, the divisor is 2x plus 1 times, and now the quotient is this is the top part in the long division. Oh God, I forgot what it was. Wait a minute. There you go. You got this. This is the question, which is x squared plus 6x plus 5. And you're done. And then you can also further factorize. Can we factorize this further? And you can write this as, so this stays the same. We can, because there is a 2 and this is a trinomial, we can write two more factors. So 1x here. So this is an easy one because there's a 1. So the product is 1, so it has to be uh, plus 5. So either it is minus 1 or minus 5 or plus 1 plus 5. So which is the one which will give the answer is, you can see, because there's a plus 6 and this plus 1 and this plus 5 add up to 6. So this is correct. If the same question was, if there was x squared minus, let's see, there was a minus 6x and there was plus 5, then you will write x and x, and then you'll write minus 5 and minus 1 because they also add up to minus. Okay, so these are the things we will see later on, a lot of problems, but I hope our goal is just to get at least this. Can you find out? So these are the two factors. So let's move on to the practice problem. So what this means is, this is question problem number 1 of practice problem, uh, lesson number 13. Okay, this you are given a polynomial this way, and it says it has a known factor of this. This is a factor. That means it exactly divides. It means when you do something like this, you put x minus 4 and this whole thing here. Remember this, what is missing here is this is x cube plus there's no x square term. So you have to put it like 0x square uh, and then plus 20x so that you get the right answer. And here, this part, see, 21x plus 20. And then you do the exactly what we did the first 10 minutes I was showing. So let's go directly to that part using long division method. So what is that long division method is? You put it like this. So the factor, that means this is the divisor. You put x minus 4 and this is x cubed. Remember there's no x square missing here. So I'm going to put 0 x square. And then there is minus 21. This is the first step to write completely to show everything. Now, I try to show step 1 that look at this x cube and this x. So this x. So you just divide x cube by x, and you see there's one x cuts off this 3 goes and you get 2, right? So it's like x, and there's one x here. So this crosses out, you get 2x, which is x squared. So that thing you could really write that number over the expression here, and then you can use shortcut now that multiply this to here and multiply here and put it right here. So when you multiply x squared times x, that is x cubed, and x squared times minus 4 will be minus 4x squared. Put a line, subtract. So when you subtract, you change the sign. This was, if you see this, there was a plus, right? So no more plus, you just change it to minus. There was a minus, this minus changes to plus. So basically it is like a plus now. So I'll take this off, and this is how it is. And you can see x cube and minus x cube crosses out, and plus 0 doesn't matter. So what is left is directly plus 4x squared. Now drop down this minus 21 right here and do the same method again, what I was showing here. So this time what you left is 4x squared. There it is, 4x squared. So that 4x squared you divide by again this x, and if you do that, 4 stays and one of the x crosses out and you get only 4x. So this 4x is written down right here. Okay, so let me take all this off, too much. So when you multiply 4x, 4x is written exactly there, and then after that you multiply This 4x which you get, you multiply to the divisor x minus 4. And then when you multiply 4x times x is 4x squared. And then 4 times negative, it will be negative 16x. So that part, this pink color thing I'm going to write here. Okay. And then change the sign. This will be minus and this will be plus. So no more that the top one. So this crosses, I get 0. And if you minus 21 and plus 16, I'm working on this one. That will be minus 5, right? So this will be minus 5. And then drop down this 20 right here. So plus 20. And this time, repeat the same thing. But this time, you're using this minus 5x. So I'm minus 5x. This minus 5x, you are going to divide by this x. And you end up getting negative 5. That you put right here. And after that, this negative 5 that you get, you multiply to the divisor and use the distributive property, and you get 20 series. So that goes right here. And then you subtract. I forgot to write one more subtract right here. And you change the sign. So when you change the sign, this will be plus, this will be minus. So no more the top sign there. Let me take this minus off. So it is like this way. And your final answer is this crosses out 0, this is 0. So the remainder is 0. What it means is has a known factor. So this is really a factor because you did get a 0. But what is important is the quotient, this part. So the main part here is that you got this thing. That means this was the dividend, right? So the dividend that you had plus 20 is, dividend is always divisor. This is the divisor. And the quotient that we got is this whole thing, right? So that part I'm going to write x squared. Okay, now. So the question is, can we further factorize this? So this is x minus 4. And now I need to write two more factors. So the number here is negative 5. And I can try to make a box if you really want to know quickly. You can put this x squared here. So this x squared and the negative 5 you put right here. So you need to have something here. So what goes here so that you combine and you get plus 4. So this is what. So what do we put there? So 5 can be split as 1 times 5. So this is the best option. And 1 times 5 is 5. And so should I put 1x and remember this is negative 5 here. Because it is negative 5, so one of them has to be positive, other one is negative. Is it this way or should I take it minus 1 times plus 5? So one of them will hold, right? But remember, there is a plus sign here, plus 4. So we need to get a plus 4. So this will be better option. So I'm going to use plus 1x and sorry, I'm going to use minus 1 right there. This is minus 1 and this is plus 5x. Okay, and then that really works. Look at this. So this basically means x squared minus x plus 5x and minus 5. And this is plus 4x, right? So I'm trying to, why we write like this is, you could do this way also and then say, okay, let's factorize what is common in the first row. You can see there's a x common because there's x here and there's x squared. X is right here. What multiplies to get x? So you get x squared. What multiplies? And this is how you can fill it out, right? There's a minus 1, so it has to be minus 1 here. And there you go, you're done. So your two factors are x minus 1, x plus 5. So a little confusing, but But you don't have to also show these steps here. This is not needed. You can use the right way to do is we'll see the later classes. When there is a 1 here, it becomes easy. So it has to be x and x. So you don't worry about what number goes here and here. So I hope I don't want to mess up too much. I hope you got this part. So next, go to the next question. Problem number 2, clearly you see there's already problem solved. So let the function p, so you're given this expression, the QB polynomial, and it says x plus 9 is a factor. Now, it already says this is a factor, right? So you're supposed to get a remainder here. So the remainder has to be 0. So right now the remainder is not 0. So what's going on? So where is the mistake the student does? So how can we tell by looking at the remainder that an error was made? So by just looking, because the remainder is not 0. So in order for something to be a factor, remember the example I gave, if I want to divide 17 by 5, it goes 3 and you get 5 times 3 is 15 and you get 2. So we say, oh, this is not 0, right? So you say, okay, 5 is not a factor. It means you can't write 5 times some kind of a number to get the 17. You can only do it like 17 is 5 times 3 and plus 2. So there is a remainder 2 here, right? So that's what is happening here. By just looking at it, uh, by just do, so that so the thing is, let the function be this, where this is a factor. But right now, looks like the remainder is there. But we can figure out, is there any error? If there is a mistake, let's check it out quickly. Okay, if you see that, let's see. This is put in the divisor. That's correct. Very nice. This is put in the as a dividend, or you can see that is also correct. And remember, I was saying this x cube. If you divide by this x, and you get x squared, and that's what you put it, and that's correct. And that x squared, Alina. So this x squared, basically, you don't have to. I'm gonna write this x plus 9. You put it right here, and you can say x squared times x is x cubed, and x squared times 9 is 9x. And you can see it's right there. But remember, what they did was directly change the sign. So this is the right way to write here. But what they did is change the sign. So instead of plus and plus, it straight away change the sign to so. Uh, so basically, this part is plus x cube and plus 9x, right? Now the student what did was, if you see this, the students wrote minus and plus. It means it should have been actually both minus, because this was the original one. When you subtract, changes the sign. So this is the mistake right there. So, mm, so on your last page, I wanted to write this step. Let's do change that, whatever. So this is x plus 9, right? So right way to do is x cubed plus 9x squared. And then when you change this become minus minus, this goes away and you get minus 2x. So let's see the look at the mistake. That's the mistake. So if the question is asked, where is the mistake done? And you can see here is the mistake. Okay, let me take this out. So this is the mistake here. This is the mistake. This should have been minus 9. This should have been minus 9 here. Then you drop down this minus 26x. And what multiplies? So I'm going to do directly now that we know you need to get this 2x squared, negative 2x squared. So what multiply x to get minus is minus 2x. And then you put minus 2x squared here. Then this 2x you multiply here and you get minus 18x, and change the sign, subtract. So this becomes plus. This goes away. Minus 26, you take away 18 from 26, get 8x. And then drop down this negative 72 right here. And this time you ask, what multiplies x? What multiply x to get 8x. You can see it has to be plus 8. And then that plus 8, you multiply right here, it becomes 72. Okay, so this one, I made a mistake here. So there's a minus, the bigger one is minus 20, so that's minus 26, and then this is plus 18, so that become minus here, right? Okay, now bring down this 72 and then ask a question, what multiplies here to get minus 8? So we'll have to change this to minus 8, right? So that become minus 8, and then multiply the same minus 8 here, become minus 72, and you subtract that 0 and done. So the error was right here. That was the question, even though they did not ask us all this work. So 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 the only question was, how can you, by just looking at the remainder, the error was made somewhere else. It's because you did not get a 0. But I still thought of showing how the whole process as, if the question was asked, can you figure out the error? And you can say, hey, that's the error. Then they could also ask the question, can you also do this whole work and figure out? Very tricky question here. Find the polynomial. So here is a question. Find the polynomial function. This for this one, x minus 1. One of the factor is already given. Remember, when you say x minus, this is a factor. That means if you plug in the plus 5 right here in each of these, you should get the answer has to be 0. All that means remember that the degree is 4. Maybe it is something like this, and it goes through 5. That's what it means. That means this is 5 comma 0. It means x and y. That means when you plug in x equals y, 5, then the output y is 0. That's what that means is. So when I say x minus 5 is a factor, x equals plus 5 is a 0 of the polynomial. It means when x is 0, the y is 0. Now, the question is, do we have to do the long division method to figure out? No, just plug this in. That's what I. So this is factor theorem. So in very near future, we'll see there's something called factor theorem. What is a factor theorem mean? So if something is a factor, how do we know it is a factor? You just say you do the opposite of that, which is plus 5, and plug it in and see you get a 0. That's all you're going to check. Let me check this one. And you need a. Now, if you really want to know whether it's a factor, there are another option is we can do the long division, and each time, let's see, do you think this is a factor? So, or you can use the box method also, like x minus 5. So if I want to know really this one, you'll have to do, my God, you can see this, you have to do 100, so many steps here. You have to do all that work just to, and then blah, 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 blah. I need to check whether you got a 0. So that's one way. Or there's another way to do is we can make a box this way. And this time we'll have 4 of them, like you see. And this is x plus 5, x minus 5 right here. And there is x raised to 4. And now ask a question, what x multiplies to x cubed is correct, right? Using this, multiplying to negative 5, get minus 5x cubed, and then use the diagonals. And ask question, there's a minus 5x squared right here. So adds to what? And you're supposed to get, sorry, this is cube. So adds to, you are supposed to get minus 2x cubed, right? And then minus 5. So the only way it has to be plus 3x cubed. And then you ask what multiplies x to get 3x squared, you get 3x squared here. And this multiply, and I mean, so much of work. So we are not going to do all this. So what we'll do is to check whether this one is a factor. Let's see, if I want to know this is a factor, all you do is, remember we have seen the factor theorem. There was x plus 2 and there was x minus 1, and this was factored form of the polynomial. What it means, we take the opposite of plus 2, which is minus 2, opposite of minus 1 is plus 1, opposite of minus 3. These are the thing where, and it's a cubic, and the graph will be going through here something. You multiply all this plus 2 minus 1 and this, you get end up getting 6. So that means that somewhere 6. So maybe it's going this way and takes a turn. So this is how actually the understanding of this. So if something is a factor, it means, let's see, this x minus 3, how do, if this is a factor, it means this is 3 comma 0. That's what well, I'm trying to say. Where if you all you do is just do the opposite of plus 1, which is minus 1, and each plug in here, plug in here, plug in here, and plug in here. And you have to use the calculator. And for this, I will allow you to use the yellow calculator that I have. You grab them and do the thing and see whether you get 0 each. So next time you put plus 1, this time you put minus 2, this time you put plus 2, and every time you plug in and see whether you get 0. So if you get a 0, then it is a factor. So the question is, which among this is a factor? You will have to do the plug in the opposite of each one of these numbers in this polynomial to check.